All right, hi everyone. I hope that you had a easy enough time doing numbers 1 through 5. First, I want you to make sure you have these values memorized for the empirical rule. That's what we were using. Remember, it was 68%, 95 within 2, and then 99.7 within 3. So I had those in there, and that's what I was using the whole time. And so for 2 through 4, I'm going to write a little note in red for you to copy down. And we are using the 68, 99, 95, 99.7 rule. You can tell that you're going to use that when you have your answers exactly on the labeled normal curve. Then I want to add at the top the normal distribution. We want to use this notation, capital N for normal, and then we have 80 for our mean and 7.7 for our standard deviation. And this notation is something that I want you to use from now on whenever you draw a normal curve. I want you to label the x-axis and use the notation to kind of explain everything. N stands for normal. Then we have our mean, mu, and our standard deviation, sigma. And it always goes in that order. So that is what we label at the top. And then hopefully you were able to get answers 2, 3, and 4. Now, number 5, though, was a little bit tough. I was just thinking of different ways that you guys would try. 68.45. If you look at this actual value right here, it is exactly halfway between 64.6 and 72.3. What was it? 68.45. And so I showed that by doing just like some algebra there to see that, okay, that's halfway through. One thing I want you to think about is that that is going to be our z-score. So our z-score is, we can do the value of 68.45 minus the mean of 80 over the standard deviation of 7.7, and that gets us negative 1.5, which tells us it's exactly 1.5 standard deviation below the mean. And so what's happening here is that the empirical rule does not work. So I'm just going to add a little note here. The 68, 95, 99.7 rule doesn't work. And I'll show you why. I want you to cross out your answer if you put 9.25. That is not correct. Because let's look up here at this. So here we have our value. I'm going to use a different color. You don't need to write all this down. But here's this and here's this. So 68.45 is right in the middle of that. And this area right here is not equal to this area right there. I'll just do something different there, like those are not equal to each other. And so really, if you look at it, maybe it's even better to do a third of the amount instead of half, like I tried. That might get us closer. But what will actually get us the very closest, and I'm just going to use a new screen, but you can keep it on number 5 still, is to look at this thing called Table A. So I want you to go to bit.ly/APstats formulas, and that's your formula sheet. It's right here. And then I want you to scroll to Table A. And then we're going to give you this in a packet when you come pick up your, or we already did if you already came to pick up your stuff. This is Table A. And so Table A gives us values. These are z-scores here, right there. And then if you look inside, probabilities are inside. So these are percentages, proportions, probabilities. You don't need to be writing on this, but if you have a copy already, you could write on it there. So what we're looking for is, well, we found that z equaled negative 1.5. If you convert the value to a z-score, then you can use this table. Remember, z equals value minus mean over standard deviation. So we found our z-squared to be negative 1.5. Here's negative 1.5, and then this top are the tenths place or the hundredths place. So negative 1.50, and we are looking for 0.0668 to be the percent. So we're gonna say right here, just something small you can add. When the empirical rule doesn't work, we use table A. We found z to be negative 1.5. We looked in the table and got 0.0668. That's a proportion or probability, and so as a percentage, we're going to write 6.68%. So when we said 9.25, we were closer than if we had just said less than 16%, but we could get even closer with table A. So that's how you do number 5 when the z-score isn't a whole number on your normal curve label. So whenever the value's between some, find the z-score, use table A, and then get that. What we're going to do is number 6 together now. I'm going to model how we do number 6 for you, and then we'll pause the video and let you finish 7 and 8. Okay, so first thing I like to do is set up like a probability statement. I think it helps me figure out what the question's asking. So for number 6, what percent of the runs will give the DeLorean a speed greater than 85 miles per hour? So I like to write P of, and then X is greater than 85. I guess I want to use red still, so that's notes. So you can write all of this on number 6. Okay. So what we're going to ask you to do is draw a normal curve for the scenario. We're going to put our mean of 80 in the middle, and then we're going to label this normal, mean 80, standard deviation 7.7. That way, we don't have to label the whole curve. Now what we're going to do is we're going to think about where 85 would be. So that's above 80. This would be 87.7. I like to label just 1 so I can get a good estimate of where 85 is. Then I'm going to shade it to the right because it's greater than. All right, now as you can see, 85 is not one full standard deviation above the mean, and so we need to use the z-score. Z equals value minus mean over standard deviation. I like for you to write the formula down and then fill it in. So that's going to be 85 minus 80 over 7.7. And then you can use your calculator to find that, and we get 0.65. We always round to 2 decimal places, and that is because when we use table A, it only goes to the hundredths place. And so we'll always round to 2 decimal places. Once we get our z-score, I like to draw my standardized normal curve. We'll label these. Standardized is normal with a mean of 0, standard deviation of 1. So I like to draw that and label that. We put 0 right here in the middle. Standard deviation is 1, and the z-score that we just found is 0.65. So it should be right about the same place that 85 was. So I'm going to label those. So this should look about the same. I'm going to label this as unstandardized. Remember, everything I write down, you write down. And then this one is standardized. And I always want you to draw both for now. And these are z-scores. Okay, now what we'll use is table A to find the answer. So I write down table A. You always want to communicate what you're doing so that everyone can see it. Oh, you guys can't see that as well. It's a little too zoomed in. Okay, so we go to table A. Now I have one pulled up. Like I said, you guys can just keep it pulled up as well all the time, or we should have given you one when you picked up your packets. You'll have one then as well. I think it's yellow. So what we're looking for is 0.65. So this time I'm going to find 0.65. The first page is negative. The second page is positive. And so we're looking for 0.6 and then 5. So that would be this 0.7422. So that you find the row that has the first digit, the tens digit, and then the column that's the hundreds that matches up. So 0.65. And we get 0.7422. Okay, so I'm going to write that down. Now I want you to pay attention to something. First of all, this little area that I shaded does not look like 74% of the curve. And I want us to think about why. Look back at this picture. This is the probability that we just found to the left. What we are looking for in this particular problem was, if you look back, we shaded on the right. And so what we're going to do is do 1 minus 0.7422, and that will get us 0.2578. And then if we want to write our answer as a percent, we'll write 25.78%. And so I know everyone's curious, what do I have to show on my exam and for all tests in here? So I'm going to write what you have to do for full credit right here. First, we want the standardized and unstandardized pictures. So we want unstandardized, oh, I can't spell that, and standardized normal curves. I want them to be shaded with the notation. And then we want the z-score formula and the work. So you have to show your work and use the formula. And then we want your final answer from table A. So that's what you'll have to do to get full credit on any of your exams. All right, let's do, you guys pause and try that exact method with numbers 7 and 8. Number 8's got a little twist, but I think you guys can figure it out. All right, hopefully you were able to do number 7 and number 8. If not, you can pause the video and copy some of this down. I'm going to go through some of the important parts in red. So first of all, we had what percent will give the DeLorean a speed between 70 and 95. I like to sometimes write this probability statement, is what we call it. You don't have to do that yet. We'll do that more and more as we get through the course. And then remember our notation. We have our standardized curve, our unstandardized curve. I'm not going to label those again because we've already done it. We have our z-score formula and then filled in with each one. We had to do one for each because there was 2 values. I used table A to find each value, but I want to make sure you guys remember table A only tells you, so if I found 1.95, it will tell me all of this area to the left. And then I find this one and it tells me all of this area to the left. So I'm just going to write, table A, area to the left is always true. And so that's why we just took the big one minus the small one and subtracted them to find the area between. So I just need to take away that white space from the big one, and that gives me my answer of 87.76%. Looking at number 8, this one was a little different. This time we want to be in the top 15%. So here we are providing you with the percent, which we can convert to the area. And so if you look at what I wrote, I have 80 in the middle, and then I know that it's 16% more than one standard deviation. So I know 15 is a little to the right of that. I'm just guesstimating. You don't have to put the standard deviation hash mark, but I like to. And so this is area to the right. The top is on the right. If you're in the top, you're above average. So it's on the right, especially for speeds. And so I like to convert it to 4 decimals because areas are inside the table. And so if I look at my table and I try to find 15%, I'm looking for 0.1500. So I don't see it over here. The lowest is 0.5. So I'm going to go to this other one. Okay, I'm going to find 0.1500. Let's see, 0.1492, 0.1515. It's between these two, but it's closer to this one. So that's the closest to 0.1500, and it says negative 1.04. So if we look here, that would be down here, negative 1.04. And that is not what we're looking for. Top 15%, if you draw your picture first, you see that it should be on the right. And so what I like to do is I like to instead, I'm going to undo that. I don't like that there. What I do instead is I find the area to the left. And so I'll do 1 minus 0.1500, and I'll be looking for 0.8500 actually. And so I'm going to go same thing over here. I'm going to be looking for 0.8500. And so that means I'm looking on the positive side, and this is more what we're looking for. So we're going to find 0.8500. Here's 0.8485. Here's 0.8508. It's, like I said, directly between these two. And this one is closer. And so that's going to be positive 1.04. And some of you might be noticing that I got negative 1.04 when I just looked for the exact 0.1500 and positive 1.04 when I subtracted from 1. And that's because the normal curve is symmetric, so it'll be even on either side. One positive z-score. It's the same area on each tail as the negative one. Okay, so that is positive 1.04. That's the z-score. So remember, that finds me the z-score. And so then I set z equal and solve for x. So you find z. I'm going to write when given a percent, then you find z from table A and solve for the value with the z-score formula. And that's what we did. We got 88 miles per hour. That should make sense. The average is 80. So if I'm in the top 15%, I should be above average, 88 miles per hour. You would get 72 if you did it backwards. So 88. All right, so hopefully that made sense. And if not, then you can just kind of rewatch this and try it again, considering all the things in red. And then now I want you guys to move on to the important ideas box. Here it is. And I want you to pause this and take the notes to put in there. I just basically organized everything that you had just done so that you can have it all in one place. Pause the video, copy it all down, and we will move on. Okay, so once you've copied it all down, now you may pause the video again and try to check your understanding. It's got 2 questions. It should be very similar to numbers 7 and 8 or 6, 7, and 8. So try those 2 and then unpause the video to see the answers and hear a quick explanation. All right, we got Jordan Spieth, distance the ball can travel. I like to use this note. We have to use the notation. Remember, here's my standardized curve on the left, and I found the z-score, got my unstandardized curve. Once I know the z-score, use table A to find the value. But remember, when we shade to the right, table A only tells us area to the left, and so that 0.0401 was here. And so to get the leftover, that's why we do the 1 minus. Don't forget that for our final answer. Now we'll look at number 2. Again, they gave us top 10%. That's on the right. I like to do 1 minus right here to get the area to the left, and then I can just get the answer right away without having to do anything crazy. So we're looking for 0.9 in the table. I can show you my table just so you can see. Here's 0.99, blah, blah, blah. Okay, 8925, 8944, 8962 is getting closer, 8980, 8997, and 9015. So this one is the closest. It's only 0.0003 away. and that is 1.28, which is where I got that z from. And then we solve for x. All right, hopefully you guys got those correct. If not, please set up some time for tutoring so we can help you, and we'll keep practicing this. This is a very important concept. We'll use it in almost every unit moving forward. Thank you for your attention. Have a great day. See you next class.